Hello class, welcome to Geometry Lesson 2-1, which is all about parallel lines. By the end of this lesson, you should be able to determine the measures of the angles formed when parallel lines are intersected by a transversal. So quickly, let's talk about what a transversal is. So if I have two parallel lines, let's say these two purple lines are parallel, and I have a line that cuts through them, that line that cuts through them is called a transversal. The example that we're going to work with the most frequently in this class is when a transversal cuts two parallel lines. But if I had two lines that weren't necessarily parallel, let's say they looked something like this, and I had a third line that cut them, it's still called a transversal. Okay? But like I said, we're mainly going to be working with parallel lines and transversals. Okay, so first let's talk about all of the angle pairs that are created by having two lines in a transversal. So corresponding angles are the first type of angles that we're going to talk about. And corresponding angles are when they are on the same side of the transversal. So let's label our transversal just to maybe make it a little bit easier to see what I'm talking about. Okay, so corresponding angles are on the same side of the transversal and on the same side of their parallel lines. So if my parallel lines are these two, don't know why that one changed color. There we go. If my two parallel lines are these purple lines right here, I'm looking for two numbers that are on the same side of the transversal, so same side of the blue line. So let's say I look at angle 1. It's sitting above the transversal. So I'm looking for another angle that's sitting above or on top of that transversal. And I'm also looking for an angle that's sitting to the left of the parallel line, the purple line. So you can see angle 5. If you look at those two angles, you see that they're located in the same exact spot, but shifted over on a different line, right? So angle 1 and 5, angle 1 and angle 5 are considered corresponding angles, or I could say angle 2 and angle 6 are considered corresponding angles. See if you can come up with another example of corresponding angles. Hopefully you came up with either 4 and 8 or 3 and 7. Okay, now let's talk about alternate exterior angles. Alternate, the word alternate means to switch. So kind of like when you have an alternate on a sports team, it's someone that can switch in for someone else, right? So it's something that switches. So alternate means on opposite sides of the transversal. It switches, the angle switches sides of the transversal. So again, if I start with angle 1, I'm looking now for an angle that's on the other side of the transversal. So angle 1's on top of the transversal. I'm looking for something that's on the bottom of the transversal. And the second word for this angle is exterior. So exterior, like if you think about exterior of a house, it's the outside of a house. Okay, so exterior is going to be on the outside of the parallel lines. So angle 1, you can see if we have these two parallel lines and I shade everything between them, everything that's shaded between, this is called my interior, and everything on the outside is called the exterior. Okay, so I'm looking for an angle that is on the other side of the transversal and also on the exterior. So you can see that the only two numbers that fit that description are 4 and 7. But there's only one correct answer, and that correct answer is 7. The reason it can't be angle 4 is because angle 1 and angle 4, you see how they touch the same line, the same non-transversal line? We don't like that. We need each angle to touch the two different parallel lines. So angle 1 touches this first parallel line, and angle 7 touches the second parallel line. So my alternate exterior angles would be angle 1 and angle 7. Why don't you go ahead and see if you can come up with another example of alternate exterior angles. Good luck. Hopefully another example of alternate exterior angles that you found were 4 and 6. They're both on opposite sides of the transversal. The 6 is above, the 4 is below, and they each touch their own parallel line. They don't share a parallel line. Okay, so now alternate interior is basically the same thing as alternate exterior, except this time we're looking for stuff that's all of our angles have to be in the interior. So remember, between those two parallel lines. So alternate means that we're still going to have one above and one below, and interior means that they have to be inside the two parallel lines. And just like with the alternate exterior, they each have to touch a different parallel line. So if I'm looking at angle 2, my alternate interior would be angle 8. What is another example of alternate interior angles? Okay, hopefully you came up with angle 3 and angle 5 as your other alternate interior angle example. All right, then we have something that's called same side interior. So instead of being alternate, same side means that they have to be on the same side of the transversal, so either both above or both below, and they have to be on the interior, so between those two parallel lines. So one example of same side interior would be angle 2 and angle 5. What would my other example of same side interior angles be? Hopefully you said angle 3 and angle 8 would be the other example of same side interior angles. Now, let's talk about the last type of angles that you learned about back in chapter 1, but I want to make sure that you still remember. Vertical angles. So remember when you have two lines that make kind of an X, it's when you have the opposite sides of those. So angle 1 and angle 3 would be an example, and angle 2 and angle 4 would also be another example of vertical angles. What might two other vertical angle pairs look like? Hopefully you said angle 5 and angle 7 are vertical angles, or you said angle 6 and angle 8 are vertical angles. All right, let's move on to example 2 and talk about these angle relationships a little bit more. So when you have those angle relationships and they are between two parallel lines, so you can see we have the arrows telling us that we have two parallel lines, there are some things that are true about those angles. So there are some angle relationships that are congruent as long as you have two parallel lines. So the angles that are congruent would be alternate exterior, so angle 1 and angle 7, or angle 6 and angle 4. Those would be congruent. So if angle 1 was 28, that means that angle 7 is 28. Okay? Another type of congruent angles would be alternate interior. So if angle 2 is 100 degrees, angle 8 is also 100 degrees. If angle 3 is 12 degrees, angle 5 is 12 degrees. Our alternate interior angles are always congruent as long as those two lines, the non-transversal lines, are parallel. Another type of congruent angles would be corresponding. So if angle 4 is 110 degrees, another angle that is 110 degrees would be angle 8 because it's corresponding. Okay? Then the following angle relationship is supplementary when there are two parallel lines. Same side interior angles are supplementary when there are two parallel lines. So if I said the measure of angle 2 plus the measure of angle 5, those are same side interior angles. They have to equal 180. Same goes for angle 3 and angle 8. Those are same side interior. Sometimes you'll hear me call them consecutive interior. That's what the last book called them, so it's still one of my habits. They mean the same thing. So same side interior or consecutive interior, you can use either one, are always supplementary when you have two parallel lines. And the last angle relationship that is always congruent that we learned about back in chapter 1, but I feel like some of you still occasionally forget. Vertical angles. Doesn't matter if it's a vertical angle, they are congruent, always. There's no exception to that rule. Okay, so I recommend keep track of these because they're going to help you solve a lot of problems later on. If you have not written this down, write this down. Or if you're someone that takes screenshots and refers back to the screenshots, take a screenshot of this information. It'll really help you later on. Okay, so the next two examples, I'm going to walk you through two different proofs. The first proof is proving that the alternate interior angles theorem works, okay? So we want to prove that the alternate interior angles theorem is a thing. So we're given that we have two parallel lines, M and N. So we're told M is parallel to N. Remember, the two vertical lines between those letters represent the word parallel. And we want to prove that angle 1 is congruent to angle 2. So we want to prove that our alternate interior angles, 1 and 2, are indeed congruent. So we start with the given information. And if I look at the picture, I see that I have angle 3 in there as well. And that's not listed in the proof or the given, but I'm going to use it to try to prove that angle 1 is congruent to angle 2. So if I look at angle 1 and angle 3, I notice that they're both on the same side of the transversal, and they're both inside the parallel lines. So they're same side interior angles. So I'm going to write angle 1 and angle 3 are supplementary because they are same side interior angles. So I'm going to use the same side interior angles postulate. Then, supplementary means that they add up to 180 degrees. So I'm going to switch this. Instead of talking about the drawing, the angle 1 and angle 3, I'm going to talk about the measures of angle 1 and angle 3. So I can use numbers. So measure of angle 1 plus measure of angle 3 equals 180 by definition of supplementary angles. Okay, so I started with my given. And knowing that I have parallel lines, I know that angle 1 and angle 3 are supplementary because the same side interior is postulate. And using the definition of supplementary, I can say they add up to 180. Now if I look at my picture, I can't do a whole lot more with angle 1 and angle 3. But angle 3 is also related to angle 2. How is angle 2 and angle 3, or how are they related? Well, they form a linear pair, and I can say the measure of angle 2 plus the measure of angle 3 equals 180. That's just adding my two angles together, so angle addition postulate. If you also said, instead of angle addition postulate, if you said definition of linear pairs, I'm okay with that as well. So now that I know that both measure of angle 1 plus measure of angle 3 and measure of angle 2 plus measure of angle 3 equal 180, I'm going to set those two things equal to each other. Transitive property, right? They're both equal to the same thing, so I can set them equal to each other. Now, I see that I have a measure of angle 3 on both sides of that equal sign. So if I subtract that measure of angle 3 from both sides, because we always want to get rid of that excess information, right? I can be left with the measure of angle 1 equals the measure of angle 2. That's just by subtracting, right? And now that I have them equal to each other, I'm not quite done yet because I want to prove that they're congruent. So I have to do one last step and say that angle 1 is congruent to angle 2. Definition of congruent angles. I forgot to write angles. Sorry. Okay. So that is one example of a 2-column proof for proving the alternate interior angles theorem. Hopefully by me talking through my thought process a little bit, it helped. You see some patterns. The more that we do proofs, the easier they will get. I know they can still be overwhelming. So if you have questions, please don't hesitate to ask. I'm here to help, okay? I'm going to do one more proof this video, okay? I'm going to use parallel lines to prove an angle relationship. And if we look at that given, you can see that we have, ooh, I don't want to move that. I forgot I colored on that picture. If you look at that given information, you can see we have a lot of symbols. So hopefully you've been studying your symbols and you remember what they mean. But if not, I'm going to read it out loud right now to help. Okay, so we're given that segment AC is parallel to segment DF, and segment BE is perpendicular to segment DF, and we know that angle AEB is congruent to angle CEB. We want to prove that angle BAE is congruent to angle BCE. Okay, so we want to prove, I'm going to draw in purple on the picture what we want to prove. We want to prove that BAE, so this angle right here, we want to prove that BAE is congruent to angle BCE. So we want to prove that the two purple angles are congruent. So I need to start by writing down all of my given information. Okay, so I've already done that. Then let's start using some of that given information. So right off the bat, I see that I have some perpendicular information. I'm just going to start there. If you started with parallel lines, that's fine. If you start with angles, that's fine. I'm going to save the angles for a little bit later because you can see our proof statement is talking about congruent angles. So I want to keep the information about angles until a little later in the proof, okay? So I'm going to jump in with the perpendicular angles. So if I know that segment BE is perpendicular to segment DF, I know that BED and BEF, those two angles, are right angles by definition of perpendicular. And if I know that they're right angles, I can also say that the measure of angle BED and the measure of angle BEF both equal 90, right? Definition of right angles. Okay? So that's just two steps right from the given, right? I took the definition of what was in the given, and then I switched it from just the definition to start including some numbers so I can prove some other things. Now, if I look at my drawing and I look at angle AED, and I add it to the angle AEB, that forms that first right angle of BED. So instead of writing angle BED, I'm going to start breaking it up a little bit. So I have the measure of angle AED plus the measure of angle AEB equals 90. And I can say the same thing for the other right angle. I can split up BEF. Instead of writing angle BEF, I can say the measure of angle CEF plus the measure of angle CEB also equals 90. That's both of those things are angle addition postulates, right? I simply took a larger angle and split it up into two smaller angles. So that way I can maybe substitute some things in later. Okay? Then, if I look back at my given, I know that AEB is the same as CEB. So look, these two angles are actually the same exact thing. So that means that if we go back to chapter 1, when we think about our complementary angles, if we have two angles that are the exact same thing, and we have them being added to another angle. So let's say, I'm just going to pretend here, the measure of angle AEB is 30. And that means that CEB is also 30 because we were told they are congruent. Doesn't that mean that AED over here and CEF would both have to be 60? So that means that they would have to be congruent, right? That was called our congruent complements theorem. So I know that angle AED has to be congruent to angle CEF. Okay? Now that I know angle AED is congruent to angle CEF, and I look back at my picture, I can say, using some alternate interior angles, that angle BAE has to be congruent to angle AED. BAE would have to be, this angle right here would have to be congruent to this angle because alternate interior angles. And angle BCE, so this angle right here, would have to be congruent to angle CEF. So that would be this angle right here. Those are alternate interior angles. So I'm going to write that. Because ultimately, remember, I want to prove that those two purple angles are congruent, right? Angle BAE is congruent to angle BCE. And I can do that by the transitive property now. I can replace, instead of writing AED, I can swap BAE. And instead of writing CEF, I can swap BCE, which is the final step of what I wanted. So that is the transitive property. I know that was probably a lot of information, but if you go back, pause, read through the proof again, read through it a few times, you start to see patterns and start to see where things are being drawn from. And it makes writing your own proofs a little bit easier, okay? Let's move on, though, and do our last example for the video, which is finding angle measures. Some of you are going to be relieved because this means that we're doing calculations, and you guys like those. So let's talk about this picture of a barn. So the white trim shown for the wall of a barn should be constructed so that segment AC is parallel to EG. So I'm going to say AC is going to be parallel to EG. Segment JA is going to be parallel to HB. And we have one more set, so I'm just going to choose a different color. And we have segment JC is parallel to segment KG. All right? So all of our parallel lines are highlighted in the same colors, okay? Now, we want to figure out what the measure of angle 1 and the measure of angle 3 should be. Measure of angle 1 and the measure of angle 3. Now notice that there's the picture of the barn with all of the drawings and the color, right? And then there was the pretty boring picture that represented what was listed above. When the book gives you more complex pictures, copy down a simple sketch of just the important information. It makes your life so much easier, okay? So now let's talk about how am I going to find angle 1? Well, if I look at angle 1, I can see that angle 1 is between two parallel lines, right? It's between the two purple parallel lines, or line JA and line HB. And if we considered this outside line here transversal, it's on the same side of the transversal as 68, meaning angle 1 and 68, the 68 degree angle, are same side interior. And what do we know about same side interior angles? We know that they are supplementary. So if I subtract 68 from both sides, I know that the measure of angle 1 is 112 degrees. So that's how I would find angle 1. Now let's look at angle 3. Angle 3 isn't really by any information that we know, right? But I can see that angle 1 isn't related to angle 3 isn't related to angle 1. They don't have any of those relationships. But angle 2 and angle 3 are corresponding. Angle 2 and angle 3 are corresponding. And if I look at angle 2, I see that angle 2 is related to another angle. Angle 2 and the 68 degree angle are also corresponding. And what do we know about corresponding angles? We know that corresponding angles are congruent. So if angle 2 and the 68 degree angle are corresponding, that means angle 2 equals 68. And if angle 2 and angle 3 are corresponding, that means that the measure of angle 3 also has to be 68. All right, and then here is a concept summary to help you guys remember all of these different angle relationships. Same side interior, alternate exterior, and corresponding angles. This is a great thing to take a screenshot of and save for future reference when you're confused by the different angle relationships. If you have any questions at all about this or anything else in the video, please be sure to ask either myself or a friend for help, and have a great night.